Question 3. One of the fastest elevators ever designed, blah, 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 will travel an average speed of 18 meters per second. It goes 571 meters up. The maximum combined load of the elevator and passengers is 1,757 kilograms. What power must be delivered by the motor to lift the elevator at the average speed? I think we're assuming that it's at its maximum load here. So let's have a look at this. I've drawn this on my whiteboard. The important information is there. All right, we have a mass of 1,757 kilograms. Our average speed is 18 meters per second. We go 571 meters up. We're asked for the power. We can get that by doing work done over time, or we can do force times average velocity. Well, we're given an average velocity. We're not given a time, but we could, in theory, calculate a time from the distance and the average velocity. So in theory, you could do this both ways. You usually can, right? If you're given the information to do one way, you can usually take that information and work out another way. The first thing we need to do here is work out what my force is, right? Even if I wanted to do it this way, I'm still going to need to know my force so I can get my work done and then divide it by the time. Now, I'm not going to do it this way because it's definitely, in this case, it's the longer way of doing it. Right? If I can calculate my force, all I have to do is multiply that by my average velocity and I'll get my power. So the force that I need to overcome to lift the elevator is its weight. Right? The force of weight. Right? So the force of weight, and you'll notice I'm drawing this slightly different now. We have so many W's coming in: weights, watts, work done. This is probably a better way of putting weight in there, although in your reference table there's all kinds of different W's and you have to be aware of which one's which. So the force of weight is equal to mass times gravity. Okay, mass times gravity I calculate to be 17,218.6 newtons. So that's my force. Average velocity is 18 meters per second. Multiply those two together and you get, let's see if I can make more room. We get actually 309,934.8 watts. The answer's in kilowatts, so we divide that by 1,000 and we get pretty much 310 kilowatts, which is answer choice C.